In this second course, ELEC 202, we begin with the solution of circuits in AC steady states using phasors. In this circuit, switches have not been operated in a long time, so it's in steady state. The sources are sinusoidal, both of them, and they are of the same frequency, 40 radians per second. So the circuit is in AC steady state, and we can use phasor analysis. Let me represent the voltage source with a peak value of phasors, 12 with negative 35 degrees volts, and the current source with a peak value of phasors, 7 with 45 degrees amperes. The reactive elements, inductors and capacitors, would be represented with their impedances, j omega L for inductors, negative j1 over omega C for capacitors. In this case, we have only inductors, and we use j omega L for inductors. Omega is 48 radians per second, and for this 2 Henry inductor, the impedance is it is positive J42, J80 ohms. For the other one is J100 ohms. That is a circuit that I will copy on to the next slide to work on its solution. But before that, what is what the question is asking us to compute? What is the power in each one of the 4 resistors at t equal 14 milliseconds? We remember that the power in a resistor can be computed with this formula, Ri squared. So we evaluate what is the value of the current in each one of the 4 resistors, square it, multiply by the resistance, and that is the power in that specific resistor. Let's go to the solution. In the phasor domain, we write the phasors for the voltage source, for the current source. We choose what is the reference node at the bottom, identify the other nodes 1 and 2, choose arbitrarily what are the directions for the currents IA, IB, IC, and ID. We're almost ready. We can start writing equations. Let's go to the calculator. The first thing we do is restore the calculator so there are no predefined variables in memory. Now we create the 2 phasors for the voltage source and for the current source. Let me define now the 4 impedances of the branches A, B, C, and D. Now I define the 4 currents IA, IB, IC, and ID. ID is a reserved word in the HP prime, so I will call it IDD. Now I define who is Vx, which is just a drop in the 25 ohm resistor, the current IB times 25 ohms. Now let me write the KCL equations for nodes 1 and 2, currents going in equals to currents going out. For node 1, IA, IB, and IC, and for node 2, IC, ID, and the current source on the far right. And now we solve the system of equation form by KCL1 and KCL2 for V1 and V2. Let me extract V1 and V2 from the list X. Because we want the power in each one of the 4 resistors, we need the current in each one of those 4 resistors, IA, IB, IC, and ID. The next step is to write the currents IA, IB, IC, and ID as functions of time, which is what I'm doing right now. Now, let me make t equal 14 milliseconds, 0.014. Evaluate each one of the currents, square them, and multiply by each one of the corresponding 4 resistors to compute the powers in each one of the resistors, which is what the question is asking us to do. And that is all for now, my students. Thank you very much for watching, and I hope to meet with you again in our next video.